Good afternoon, all of you. It is with great pleasure that I extend a warm welcome to our distinguished panel for today's session on intercity operation of electric bus, trucks, vehicle to grid, and electric highways. We are honored to have Mr. Anand Singh, AGM ISGF, to moderate and theme presentation of this session. Welcome, sir.
Thank you, Vivek. I think Neha will be joining shortly, so we will start. Thank you everyone for joining us. So quickly, I'll do a theme presentation, and then by the time Neha comes in, and then we'll start our panel discussion. Thank you. Thank you. Welcome everyone for the next session. And then we had a very elaborated discussion regarding the trends for EV charging infrastructure. Now we are moving to buses and trucks. So we have people here from bus industry and utility as well. So we started this electric mobility in 2009 when NEMP was launched. And then we had FAME 1 in 2013, then 19 we had FAME 2, and FAME 3 is also ready to be announced. So we mostly saw that we have been talking about buses only. And we hardly saw that anybody is talking about trucks, neither in private nor from government side. None of the initiative was taken. So we thought of, let's see that why it is not happening, and then what is the motivation regarding against going for a truck pilot. We did a truck, we ran an electric truck from Lohari to Ludhiana, that is 415 kilometers distance. So before doing that pilot, we tried digging out that why trucks are not picking up, why only we are talking about buses only. So we did a analysis wherein we found out that all of the carbon emission that is happening in country, buses and trucks are emitting only 37.8%. So this is the kind of carbon emission that is happening. Out of that 37%, we realized that buses are emitting 9.55% only. So that is almost 1/3 share of the carbon that is being emitted by the larger vehicles. And 28.25% is emitted by trucks, and we didn't have any initiative for the trucks. So we took that initiative and we tried doing a pilot. Let's run a truck, establish that that is possible, because you have to go outside the city. We have to ensure that there is enough charging infrastructure available so that you can charge the trucks and then you can move the cargo. So we started a pilot. We had everything. We had funds. We had great enthusiasm to do a pilot, but we didn't have trucks. And rest everything was there. So we started finding out that where is the truck, where is the truck. So across India, we tried contacting people. There is a local OEM also in Gurgaon. They are IPL Technology, their new startup in India. They provide trucks. So I contacted them and realized that the kind of trucks they are making, that is not suitable for freight movement. So that was not happening. I again moved up, tried contacting to a vendor based at Hyderabad. And then I was promised that I'll get the truck in 3 months. And we started from the smaller truck, that was Tata 407, and a retrofit model one, so that we can start moving out and charging the, because of the lower capacity of battery, it is easy to move it, and then lower capacity of load also, it is a little easy. Um, in between my presentation, I'll welcome Neha. Please come to the dais. We understand the transport problem. So I was promised that you'll get the truck in 3 months, but when I reached back to them in 3 months, I was told that we will take next 3 months to give you the truck, and we have changed our strategy, and we are going for a larger truck that would carry 28 ton of load. So I thought of let's wait for next 3 months. Again, I went back to them after 6 months, and then I learned that they have again changed their strategy, and now they are going for a 55-ton truck. So now we were slipping on time, and it was very painful not getting the truck. Rest everything we have. So I thought of, it's very difficult to bother somebody who is sitting thousands kilometers away from you. So I found out a local solution. I reached out a OEM based in Noida. And it was very easy to bother them also. Every week I'll go to them and then I'll ask that where is the truck, and they'll also say that next month we'll give you. So we got the truck, but the problem was we didn't have the RI certification. So before coming to the road, you have to take that RI certification so that you can drive it. And it started that way. Then we reached out to RI and then helped them getting the certificate. And finally, we got the truck. Though we slipped like it was like a thrilling movie wherein we would not know that where we are going to get the trucks or not, where we are going to get the pilot done or not. So in the pilot, there are like certain things we did to demonstrate the pilot, consulting freight operators, charge point operators. So the entire ecosystem, you have to understand that, wherein everybody can come on board and then they can help you so that you can do the pilot. For intercity operations, the biggest challenge is that you have to ensure that all the chargers across road are working. They are not out of order, and you can charge the truck with it. So I'll show that there are a different model of trucks. So we tried two models deliberately. One is a smaller version, that is Tata 407. It's a retrofit model, what I was talking about. And another version was, this is IPLT Rhino 5536. So this is one of the biggest model that is available in India. And incidentally, this was not made for freight application. This was made for mining application. It was working well there. But in the beginning of the pilot, when I had approached them, they said that we don't have the truck what you are looking for. By the time we realized that, can we not use your tractor for the freight movement? And they said that yes, you can use it. So I assumed that they'll give me the truck that can carry the freight. And we actually did recce 3-4 times right from Delhi to Ludhiana to understand that what kind of charging infrastructure is there. Will it be suitable for our trucks to charge? What kind of charging time is required? So we did dry runs, lots of dry runs, and then we actually moved freight from Luhari to Ludhiana several times to understand that how does the truck is working when you are without load, with load, what is the efficiency, and then what is the time lag when you move from ICE engine to electric trucks. So this was both the model of trucks we did took two routes. One was the smaller version was used for Delhi to Chandigarh route, and the distance was 347 kilometer. Average speed was 45 kilometer. Charging time was high, and then stoppage time. So actually, when we are doing this pilot, we noted down everything rather than depending upon the Google. We tried understanding that what actually the numbers are. So let's do it, understand. And then it was December also, so traffic condition was also not very supportive. Another pilot we did, another pilot run was done with a bigger truck, and now the distance is 415 kilometer. Average speed was very high. This is more than the ICE engine truck, and that was wonderful thing that came out. It is 55 kilometer per hour. Charging time was 5 hours, and total stoppage time in between was 9 hours. So electricity consumed, where the good thing is it's only 550 kWh. So you can imagine the kind of cost one can save once we switch to electric mobility. But there were several challenges. Few of them were no charging station at warehouse. So we understand that this is kind of pilot. We first started, this was first pilot. So we have not yet designed our warehouses in a way what can support charging infrastructure, what can support electric mobility. Because there is enough space, but there is no charging space. So you have to put your charger there, then only you can work with them. Most of the bigger trucks that is available in India, they are 32 feet. All the bigger trucks. And special purpose vehicles are like bigger trucks, what carries smaller cars, they are big in size. Otherwise, general freight is being carried out by the bigger one is 32 feet trucks. So when we tried doing this, the truck was 40 feet. The chassis was 32 feet, but there is no standard freight, there is no standard container that supports 32 feet. It's all customized application. So we had to get a 40-feet trailer so that we can carry a 40-feet container and then we can move it. So we arranged the 40-feet trailer, then we arranged 40-feet container so that we can fit. And that supports the third-party logistics wherein it supports all models of the freight wherein you can put it on train, truck and ship. So that was important to establish that we are sticking with the standard so that going ahead we do not face any problem. Most of the states, and there were several other problems what we realized during our pilot, that it's very difficult to obtain high power electricity connection, high cost. We paid almost 20 rupees at some charging station, 22 rupees at several other charging stations across the highway. Most states, the upper limit of LT connection is below 100 kilowatt. So once you are moving into trucks or buses, your charger needs to be more than 150 kilowatt, 240 kilowatt, of the order of 200, 240 kilowatt. So it is very difficult to get that. Now we see that loss of charger coming in with a higher capacity. Availability of land and on highways for setting up charging station is also very costly affair. There is concessional EV tariff, many state levy demand charges also. So there are special tariff for EV, but there is demand charges that is very high. So to pick up this business, it is not very supportive. Megawatt scale charging has to go through HT only. So that is also another problem. What we realize, if you want to run trucks, you have to have a charging station that is of the order of megawatt scale. So wherein you have to get a megawatt scale connection, once we tried understanding that what is the kind of money that is required to take up megawatt scale charging, so we approached the concerned utilities. Publicly owned utilities, we found that the service charge was 3,000 rupees per kilowatt. And another utility, we learned that to get a 1 megawatt hour charging, 1 megawatt hour connection, you have to spend 1.25 crore to 1.5 crore. So this is the connection charge. Then you have to have the infrastructure charge. And then we learned in the first session that occupancy is only 4 to 5%. And on the higher side, AASL claims that they have 2 to 3% of occupancy. Tatas are claiming that they have 3 to 5% occupancy depending upon the kind of place it is, or urban or rural setup. So that makes the entire business very risky, and it takes courage to people to convince that yes, this is possible. The time limit range on single full charge restricted the distance of truck could cover, because when we started, the batteries are very, very heavy. So for the smaller truck, the total load capacity was 6.25 ton, and we could carry only 2.5 ton of the payload, because the batteries were very heavy. And if we increase the size of the battery, we'll end up carrying batteries only. We won't be able to carry the cargo. So there was a bottleneck wherein you have to understand that what is the trade wherein you can reduce your range anxiety, then you have to charge several times more. So there batteries are going to play a central role in this entire initiative. The key findings were, and we did a ROI, then cost benefit analysis of entire thing. And these are like actual figures, what we spent on road, we recorded, and then we did the entire thing. And similar thing for all ICE engine trucks, so that we can understand that what is the difference between ICE engine truck and then an electric truck that is coming on the road. So payback period for the bigger truck was around 8 years, whereas 7 years for retrofit. The smaller truck, the ROI was, payback period was less. Green gas reduction was 48% for the bigger truck and for 68% for the smaller truck. Total diesel displacement was 75,000 liters. I mean, this is huge number, and in the previous slide, we could discuss that it was $118 billion import of oil per year we do. So this is the potential what electric trucks or electric mobility can solve in terms of when we start thinking of moving our freight through electric trucks. Total cost of ownership was, for the smaller truck, it was 14.84 rupees, and the bigger truck was 9.12 rupees. The total cost of ownership for the bigger truck was 29.2 rupees, Rhino. So it's kind of, we have calculated the cost of electricity, what we got in field, that was 22 rupees, but it will come down when we can arrange the cheaper electricity than can be bought, and that can be arranged from maybe solar or renewable resources across highways. So the cost may also come down once we understand the entire ecosystem, make better partners wherein it makes better business sense. So that is possible. Policies for cargo movement by electric trucks. So these are like a recommendation wherein creating megawatt scale charging facilities. So there should be some initiative or some leeway from government side, also from utility side also, wherein a private party can dare to get into this business, because this is very costly, and we understand that occupancy is also very less in the beginning. So that makes the entire thing risky, that make it look risky, but it is not. Highways electrification are also a challenge. Fortunately, we had 11 kV line running across the road from Delhi to Punjab, because in Punjab or in Haryana, you have 11 kV line running across. So that was one good thing. But the challenge was all the feeders that was lying across highways almost were rural feeders. So now you don't have 24/7 electricity supply to those feeders. So while doing Rekhi, I saw buses, electric buses have been running. They are into intercity operation, and I have seen electric buses are being charged by gensets. So that's not the good condition. So wherein this also needs to be taken in account, where to promote electric charging across highways, some rural feeders can be used in a way so that we can make available more electricity available across the day, so that it serves the purpose. Charging with green electricity is also one thing what can be promoted, and government support for availability of electric trucks. We don't have any concession, any scheme for electric trucks. What has been given to all public buses, but not for trucks. The biggest challenge was the cost is very high. If you go to buy a 55-ton truck, it will cost you 1.2 to 1.25 crore. But similarly, parallelly, if you are looking for an ICE engine, you can get it in 65-70 lakhs, the similar GW capacity of truck. And this entire market is very unorganized. Almost 70-80% people have less than 5 trucks. Very few people they are into fleet, big fleet operators, wherein they are big in numbers. So just because of the way the entire thing is organized, it's very difficult to convince some people on grassroots level, wherein you have to pay almost twice of your cost to get the same freight when you are moving your truck from Delhi to Luhari, because that market is very saturated. There is cutthroat competition on the freight side. So now you have no incentive of running electric truck from the freight side. But yes, there are incentives in terms of carbon diesel displacement or carbon emission. So we did run and we could understand that what it takes. We established that we can run electric truck across highway. We did it. Technically this is possible, but now we need better business models wherein the entire ecosystem can come together. And one has to hedge the risk of individual party, where this is freight operator, where this is charge point operator, where this is truck OEM, and whether this is investor who is putting their money. So once we are able to do this, there are possible innovative business models wherein we can certainly do it. I have a very high confidence regarding if we do it right, we can do it well. Next good thing would be, we did the electric truck. So next thing we are going to do is vehicle to grid. A bit of discussion happened in our first session wherein is the grid ready. We did a pilot to understand that whether the grid is ready. We did it in Calcutta, and from FAME to Calcutta is expecting 1180 electric buses to come to their grid. CSCs handling most of the depots were lying in CSC area. So we did a pilot in CSC area wherein we have to understand that how we are going to adopt all those trucks in years to come. It's like 2 years, you'll get to see all the electric buses to come. Buses are running across your depots. And the result was outstanding. They have managed it so beautifully that the kind of load is 68 megawatt load is required to run all those buses, and not even a single transformer was required to replace in the utility. So this is possible. You can and not, it's not happening in one day. Gradually you will be running 5, 10 trucks, 20 buses, 30 buses as in when required, and you will start keep changing the depots also. So we have to understand that how we are increasing the load, and then it will balance itself, and we have to understand the strategy also behind this, that how we are going to put the load on the grid, and then how we are planning our depots and how we are planning our charging. The V2G it has not been done in India. First time we are trying to do this, and this will include selection of appropriate EV. There is no retro V2G EV available in India, so we have to rely upon what is available and whether we can change it. So we are going for a retrofit model wherein we'll get a car from maybe a very prevalent manufacturer, and then we have tied up with the University of Delaware. They are pioneer in V2G. Since last 25 years, they have been advocating this, but now this is taking traction in India. And doing this entire exercise, we figured out a very interesting outcome wherein Delhi is running more than 250 buses across the city, and every bus is carrying more than 250 kWh battery on it. Delhi has a plan to scale it to 5,000 buses in times to come. From grid side, when we look at it, Rajghat depot has been given 4 megawatt of power, and then Rohini it was around 12 megawatt. Once we scale up and move, and look at the number wherein you are going for 5,000 buses, this is going to be huge in numbers. Huge capacity is required to change into all electric buses. But there is a better thing also from the other side. Now you have a portable battery that is kept on your bus running outside. If we take that 5,000 figure and assume that 20% buses are always lying well servicing and something is happening, or 10 to 20% buses are in depots, rest 80% are on roads. If you can use that battery, that will give you a cushion of 250 megawatt hour that will help utilities to meet their peak demand, wherein you are buying electricity at a very high cost, and being into a regulated market, you cannot charge more. So that will give you a cushion, wherein anyway buses, after running 5 years on the road, you have a secondary life of the battery where that can be used in storage. So these are like all good outcomes what we could understand, that we can work with it. The idea is how strategically we plan it, and then lots of studies that are required to be done in the beginning so that we understand that what not to be done. So I'll end up here and then we'll quickly move for the panel discussion. Thank you. So we have Sridhar Chari from Ambassador Bus World Foundation. So I'd request if you have a presentation, then we can start with you. Okay.
Can you all hear me? Am I audible? Yes? Okay, so I think it's, first of all, it's fantastic weather, and it's been a lot of presentations for you all this time, with a lot of numbers and facts and figures. So I'm going to spare you the agony. My presentation is going to be very short, 7 or 8 slides, something I believe will interest you and keep you on your seats, right? So thank you very much, ISGF, for this opportunity to Busworld to speak at this session. It's a very, very well-structured event which covers the entire value chain of the e-mobility sector, right from power generation to mobility at the end. And of course, a lot of topics come in, as we can see from this panel. So different stakeholders are represented here. So in a nutshell, what is Busworld? Busworld is an organization headquartered in Belgium. We organize shows in Europe, in Turkey, in Southeast Asia. We did have a show in India some time back too. But more than that, we are a knowledge company. We like to facilitate dialogue when it comes to imperatives of the bus industry, what kind of policies, what kind of common interest, what kind of lobbying, what kind of future measures should be taken, right? Is it better? Yeah, so we try to bring together different stakeholders in the bus industry and try to ensure that their voices are collectively heard. So we represent them, we undertake projects, and we have knowledge that is shared across the sector. As explained earlier, Busworld has been around since 1971, and we have 3 shows that we organize across the world. We have a show that's coming up in Indonesia now, and we organized Busworld Europe in October last year. A few thoughts from our end based on our global studies. So I'm going to very much present a bird's eye view, something that is going to be drawing from a global experience, which will have bearing on India, I hope. A couple of slides here. If you see, when you see zero electric buses, it's very, very clear that China is a leader. But what is startling is the gap between the leader and the next few people. India might be 4% when it comes to city bus adoption in e-mobility, but it's only 4% compared to 97% for China. And even Europe is only 24% still, despite all the talk. So China is clearly it when it comes to electric vehicles. And in terms of coaches, we could be called 0, we could be called 0.1, it actually doesn't matter. I mean, except for a few routes, I know there are electric buses running between Mumbai and Pune. We don't really see so much traction for electric vehicles when it comes to the intercity segment. And I'll touch upon that in a bit. So there needs to be progressive policy and some kind of structuring of our network to ensure that this happens. This is a very complex, very busy slide, but bear with me. I mean, there are 5 heads when we look at the charging ecosystem around the world. Whichever country you take, these 5 parameters tend to be the same, and they are the most challenging if you take them together. Primarily, it is who owns the charging infrastructure, who manages it. Often, it's not the same person, it's not the same team. So how do they allocate responsibilities, right? Who pays for it and how? Is there subsidy involved in the process? Technology, we heard a lot from different people. There are different charging standards, there are different power voltages, there are different mechanisms in the buses for charging. It's like an iPhone charging vis-a-vis a Samsung charging, right? It's different. Placement and accessibility. It's one thing to say that we have 5,000 charging stations, but where are they located? Are they on the highway? Are they in the inner city? Are they in buildings? Which vehicles do they cater to? Because the charging system that you need for a passenger car is going to be very, very different for what you need for a truck or a bus or for a two-wheeler. What is the extent of public funding we're talking about? When we talk about charging systems, to what extent is it subsidized by FAME? That's not very clear. We need a lot of public-private partnership, and it's even more challenging because charging technologies keep changing all the time, and charging system providers don't necessarily talk to one another. So therefore, it's very difficult to aggregate scale on this. Finally, a few points to ponder. There were a set of talking points that were given to us. I thought, let me just reflect on a few of them and build on what was discussed in the earlier session. So, I want to take a very global and a common sense approach to this, not get lost in jargon or numbers, right? So before we talk of advanced battery charging technologies, we must talk about battery supply chains. I mean, it's okay to talk about a charger that charges a bus in half an hour. But the key thing is, where do the batteries come from? Today, fortunately or unfortunately, it seems to come only from one country, right? So typically, even in Europe, we have examples of European bus manufacturers who have lost contracts because they didn't have control over the battery supply chain. So till we can indigenize in India and we can develop a strong battery manufacturing facility, vertically, horizontally integrated facility, we really cannot talk about different battery technologies. And that is really very, very important. The next thing is, there are different charging models. Before I worked with Busworld, I worked with Volvo, and I have lived in Sweden, and I know that there were a number of charging technologies that were being talked about. There is opportunity charging, which basically means you can charge every 10, 20 kilometers along the way. It's good for city buses. But it needs to be extremely efficient. If you don't have the right route planning, if you don't have traffic management, it doesn't really work. There is fast charging I mentioned earlier. Fast charging is an excellent concept, but are the batteries ready for it? Is the infrastructure ready for it? Because even in Europe, there have been instances of batteries catching fire with fast charging. You suddenly get a surge of power, and that's not necessarily good news for the battery. It's also cost. How much are you willing to pay for charging, per charge? Power in India is, first of all, ostensibly cheap, but it's not always available. So do you need to charge from a generator to charge your battery? Because we've had scenes in Pune, I think I did see a bus that was being charged by a generator in the middle of the road. So we don't want that to happen. So the solution might be battery swapping. Battery swapping is not efficient. We've heard views wherein we've said that different temperatures, different conditions, different technologies have a bearing on what kind of batteries goes in. So no two batteries are exactly the same. But the good news is in Korea that they have developed a mechanism to swap batteries in 30 seconds. So, and I think in Mumbai, if I'm not wrong, Switch Mobility does the same thing. So Switch implies battery swapping. So perhaps battery swapping might be the way to go in India instead of investing in very expensive or high capital cost assets. Now, we had an excellent study on truck charging and the pilots that have been undertaken. My congratulations to the team that has done this. So we also tend to think that given the challenges with respect to intercity coaches, typically the range would be about 300 kilometers normally. right, for a intercity coach. Mumbai-Pune works because it's only about 180 kilometer tops, even if you take all the city conditions. So one charge will be enough for you. But if you need opportunity charging, if you even need to go from Delhi to Jaipur, which is 300 kilometers slightly here and there, you still need to have some kind of buffer. And you cannot have a bus full of passengers who have to wait for 1 hour for the bus to get charged, or, like I mentioned earlier, to have a fast charge and risk a fire, right? So potentially we need to figure out how do we charge intercity coaches in a good way, sustainable way. Truck charging might actually work, but not for critical components, not for e-commerce components or perishable goods, because people can complain, goods typically don't complain unless the owner of the consignment complains. So that's something that we need to think about. For V2X technologies to succeed, even globally there have been experiments to feed power back to the grid. But again, the problem lies in the varying loads of power generated by the asset, the quality of the batteries, the connection to the grid, the infrastructure, the financing mechanisms, the carbon credits, etc. So all these things need to be resolved before we can think of feeding power back to the grid. It has to be a profitable model at the end of it. School bus electrification, we've discussed this. School buses are interesting because there are a number of models in which they can be operated. They can be owned by the school, they can be leased out by the school through a contractor, as typically happens in India, and the contractor can then run the buses for other duty cycles. So if the school bus has a very diverse duty cycle, it will have different peak hours or off-peak hours in which it can feed power back, or it can allow more flexibility. But typically, if a bus is owned by a school, then it will only run for, say, 7, 8 in the morning to 3, 4 in the afternoon. So that might provide a window to opportunity charging or feeding power back to the grid. Finally, electric highways and induction charging. This seems to be a very interesting idea. Now, when we say electric highways, there are 2, 3 ways to look at it. Are we looking at charging points at fuel stations? Point one. Are we looking at trolley buses? Because that's a very different technology and it's not very cheap. Or are we looking at induction charging? What do you mean by induction charging? You mean by putting induction chargers on the ground on which buses will run, right? That seems to be an intuitive way. No wires, no connections. The bus gets charged as it moves. But the problem with this approach is very much that when you look at induction charging, there are as much as 35% power losses in the process. We know of European companies that have tried this. There are electric highways in Sweden, but it's remained a very interesting novelty, but it has not really scaled up for this reason. It's expensive and there are power losses. So beyond that, the question to be asked, which I've not put on the slide is, electric buses, really, what is the real total cost of operation? Do we have a clear idea without subsidies? That question has to be answered, okay? That's one. Even in China, it still remains a very subsidy-driven game. So do we really have mastery over battery technologies? Is battery technology really advanced enough? Is it going to change much when we make projections of buses being acquired in 5 years or 10 years? Are we factoring the technology change in the process? Are we talking of non-metal batteries? Are we factoring Toyota's new engine, which runs on water, right? What happens if you have that technology? You may not need electric vehicles after all, right, at the end of the situation. So we need to look at all these imperatives. We need to look at, is it just probably a good first step to have more buses on the road and then electrify them rather than looking at electrification as the first point and then move to the next point of having more buses. So that's basically what my summary to all of you is. Thank you very much for your time.
Thank you, Mr. Sridhar. Thank you for your points. In fact, very interesting. One of the complex slide what you shown, wherein we talked about the technology and the ownership. Eventually in India, what has happened? We have gone to the GCC model. Earlier, it was only the bus operator or the agency that is running the buses. So they had to buy the bus, then they have to learn the electricity management, then they have to get the connection, and they have to do all the running around. So CESL has done a wonderful thing. They gone for a GCC model wherein you don't have to worry about what needs to be done. Being a bus operator agency, you just have to tell that how many kilometers, what is the route, and this is the per kilometer charge. So that in a way they have very beautifully outsourced all their headache to the service provider. On the other side, what has gone right is now the person who is an expert of doing everything understand that how I can play my game so that I can add value, maximize on the efficiency, and then make money out of it. So that has been a wonderful thing that has happened in FAME 1 then 2. So now anybody who is a service provider has to understand that how they're going to operate the bus, whether they shall be able to make a megawatt level charger on the depot. There are, huge places available where you can create solar charger and then you can use the same solar and you can use as a very cheap electricity rather than buying from the grid. That is also one possibility. Another thing is, can we create a battery storage with a secondary life of the battery, what is currently running in the buses? So that is another opportunity what one has to look, so that they can maximize their profit. So all the responsibility of innovation that service provider is taking, that is one man, and that is one good thing what I have seen in last 10 years that can be dealt beautifully. So thank you very much. Now we would move to Mr. Biju PT. He is Head Idea and Incubation Office, EME and Asia Pacific region. If you have your presentation, please.
Hello. Good morning, all. Can you hear me? Yeah, okay. So my name is Biju. I am leading Idea and Incubation team in L&D, where we scout for new ideas by working with startups, universities, and we are also collaborating with the multiple industry bodies and coming up with some of the disruptive solutions for the power transmission and distribution vertical. So here actually the topic is about evolving trends in electricity mobility, especially on the intercity operations of electrical buses, trucks, vehicle to grid, and electrical highways. So I thought of bringing some insights by looking at what other countries, what they are doing actually. Here, some of the panelists, they were talking about a megawatt scale of charging infrastructure, and that is the need of the hour if you want to bring electrical buses and trucks on the road. So how do we do it? We don't even want to reinvent the wheel, because there are countries actually, they are piloting some of these models in their countries like Sweden, Germany. We just need to look at how they are doing it and then see how we can learn it and how we can improve further in order to adapt the Indian road conditions. So electric highway, if you look at it, it's an innovative concept that aims to revolutionize the transportation by integrating electricity into road infrastructure. So here, there are three types of technologies being adopted, like overhead power lines. In some countries, they are deploying it. And ultra-fast charging, actually, ultra-fast charging stations, they are deploying it. And a new concept called wireless charging is also at play. And apart from that one, I also want to talk about portable charging stations. And it's a new and innovative concept of making charging station on the wheel to remote areas. So here actually, we want to bring not only highway, all the remote areas also, then only we can target for a greener environment. So let's focus on these areas. So as I have mentioned, electrical highway provides electricity to the moving vehicle. There are several benefits, and if you look at it encourages the adoption of electric vehicles by providing reliable and efficient charging infrastructure. And it also reduces the emissions. We can significantly reduce greenhouse gas emissions by bringing electrical highways. And electrical highways enables continuous charging while vehicles are in motion, making them energy efficient options. And it also enables net zero transport sector. So, first example, actually, I want to quote for the electrical highways with overhead power line solutions. So, as it was showing in the picture, the overhead lines are actually put it together like how a electrical train is getting charged or how a tram is getting charged. And this involves a huge infrastructure cost basically. But I am glad to know that India government is actually announcing they want to electrify the highways around 6,000 kilometers in the Golden Quadrilateral connecting all the 4 metros. So this is a good news. But before getting into a final solution, we have to study what are the other solutions are also available. And here actually one of the risk actually, if you look at risk of overhead wires falling on the highways, that will cause accidents. So there should be a constant monitoring required at every point of the highways. So otherwise, actually, this is going to create a lot of accidents. Then also, policy support is required. Government needs to provide a clear policies, incentives, and regulation to encourage this kind of adoption. And more than that, we need to look at a holistic platform that is required for managing the charging infrastructure and highways by connecting all the charge point operators, utilities, energy management systems all together. So, this is another concept, like this is wireless charging on the highways, and this concept is being implemented in UK. The concept is like, we are actually dedicating a separate lane for the electric charging. So, consider a scenario, you are now moving on to this lane and the vehicle is getting charged. And this can open up a lot of opportunities also, where if you really look at it compared to the overhead lines, here there is no visual impact on the highways, and the accidents are less actually. It is more safer approach, and continuous charging can be achieved here also, and this is being implemented in UK. So the challenges is, see, when we are going to implement this kind of infrastructure for Indian roads, so we always look at a 50-50 chance of a failure or success here, because the road conditions may be different compared to European countries or Americas. Here actually in the highways, I could see that highways may be open, but there are a lot of cross-walking of human, cross-walking of animals. All those things are coming actually. So we have to really pilot it and see how it is working for 3 to 4 months and understand the impacts, and then finalize a solution before we implementing it. And here, beyond actually, just charging on the highways, we can also imagine a situation that suppose you are driving on this electrical highway and you are actually using your V2G technology to power that highway actually. Okay, so you just drive to your office and you earn the money also. So that kind of concept actually is not implemented anywhere. Probably actually, we can think of from India actually, when we are actually adopting new technology, we can actually adopt with some new disruptive innovation also. Another charging infrastructure is that is flash charging. Okay, this allows ultra-fast charging at intermediate bus stops to optimize overall charging cost. So whenever bus is actually getting stopped in a bus station, that time within 20 seconds this bus gets charged, and then actually it do not require to charge at every station. It may be after 4 or 5 stations, it will again get charged. So this technology is actually is available, so we can actually use this one. This also will not create any visual impact on the highways, and this is one of the technology, but the cost factor is always come. Okay, so you have to evaluate that one. So now I want to talk about a new concept of a portable charging station. So here the more focus is on how do we bring this charging station in remote areas where it is not feasible to pull high tension cables, okay, or build a charging infrastructure, or it is taking more time to build such infrastructure. How do we go about such situations? So this is a concept called portable charging stations, where we can make a charging truck. It carries the BESS container. BESS means battery energy storage system, and this can actually powered up from a remote grid, and then actually it can carry to a isolated highways or remote stations, and then allow the vehicle to charge on the highways. And you can charge a premium cost also for such situations, okay? So the challenge is, there are multiple challenges. Here, when we look at the ROI of the entire system, the truck cost, battery energy charging, the container cost, everything will be coming very huge cost. So instead of actually doing a plug and play here, we have to really look at a customized trucks built only for this one by collaborating with the truck manufacturers. And we need to make a optimized charging station infrastructure. Here, only DC to DC charging is required here. And also, some vehicles can come and charge, or using the V2G concept, we can charge this BESS container also. So these are some of the concepts I want to explore here. So if you look at the bigger picture, the intercity bus transport market in India is estimated over $15 to 20 billion, okay? So this is a huge market, and investments in highway expansions are driving the growth of 10% CAGR. So electric buses can play a pivotal role in achieving national fuel security and reducing emissions. Some of the use cases which I have explored, that Britain is about to test this electric charging while you drive. That is what I was actually taking that picture and showing. Over the next 5 years, UK is actually really investing 500 million pounds to stay on the cutting edge of the technology. And this you can refer it. And similar way in Sweden also. Now Sweden is actually trying to expand their e-motorway. That is also wireless charging infrastructure, and they are targeting to expand for 3,000 kilometers by 2035. Okay, and it's not only actually wireless charging infrastructure is required. The EV car also should be compatible for the wireless charging. So there are a lot of new innovation is happening at the EV side to make the car also portable for this kind of infrastructure. Okay, so from L&D, we have multiple charge EV solutions. We have charge management solutions. We have a hybrid energy management solutions. I just want to touch upon some of these solutions here. So we have our own homegrown charge point management system, and this can be used at any scale. We have built our own charge management application in our own campus in Chennai headquarters, and we are actually providing these charge management solutions with the open charge point protocol standard. So any charging infrastructure can be compatible to our solutions, and this can provide a seamless charging infrastructure management. So some of the campus implementation, this I thought of actually highlighting here. Then we have another product, another solution actually. It is called a SHEMS, Site Hybrid Energy Management System, where actually user can monitor the EV charging across site. Operator can visualize the real-time status of the electrical vehicle and provide a user management, real-time view of the system, bringing visibility to every stakeholders. And this is also integrated with the GIS map. And we are also have provided advanced analytics so that energy consumption patterns, energy demand patterns, all those things we can analyze it and provide adequate charging infrastructure. So some of the key takeaways, we have a lot of technologies around EV charging infrastructure. It is an evolving field, and wireless charging, I have explored that it is a safer and more sustainable solution going forward, but the cost factor is always there. And also, we have to look at the standardization required for a different technology interoperability and communication interfaces and charging infrastructure. Otherwise, the consumer will face difficulties when they are moving from one station to another stations. So here we need a holistic platform bringing complete visibility of charging infrastructure management, fleet management, energy management with advanced AI ML based recommendations for load management. Then only we can actually ensure that this system is sustainable and reliable for a long term. And for that, the government, utilities, policymakers, regulators, solution providers, and R&D organization has to work together for piloting some of the promising technologies and perform a detailed study before finalizing the solution. That's what I want to tell. Thank you so much.
Thank you, Mr. Biju, for bringing all the innovation to the dash, and a couple of very eye-opening things wherein the Indian condition will support it is your overhead power line charging. So we think that we are in the truck business, but we are in the battery business. So eventually you are, because the cost of the truck is half of the cost of the truck is the battery. So whether it's very confusing that whether we are in battery business or truck business. So once you go overhead, we keep crying about there is no charging infrastructure, the batteries the trucks are costly, and we keep crying about it. So let that problem be handled by the government. Our transport minister has promised that we'll see a overhead charging line in India very soon. And let government put some money in it and enjoy the benefit of technology. This will actually enable the cost of the truck will go down, because anyway you'll have some onboard battery, and once the battery cost is very low, or some subsidy can be done. It's at par with IC engine truck, and that is the condition wherein people are agnostic to IC engine and an electric truck, and that gives the biggest push for this adoption of the electric mobility. So thank you very much. Now I'll request Mr. Pramod Kumar Mishra, who is Head Distribution Planning, BACS Rajdhani, for his presentation.
Thank you, Anandji. Thank you. Good afternoon, panelists and audience, and thank you for being with us even at the lunch time. So thank you so much. I'll have quick presentation, and this will be mainly on the utility side and the network side. And I'll try to dwell upon how simple tweaking in the planning approach can economize this journey. So I'll give you a few practical cases which we have implemented, and that saved a lot of cost to exchequer, government or operators. Actually, I personally feel like more than 2 decades in the industry and distribution business, this time and next 10 years is going to be the most exciting times. And I'm fortunate that I'll be there for next 10 years as well. So this is a very interesting time, and I have seen that a lot of things are coming up. In the last slide, it is seen that the wireless charging. So when we are talking of flash charging, at the same time we are talking of wireless charging. So these two things are probably going to happen in next 10 years. And India is poised to lead this journey for next year, because we are almost clean slate. We can start afresh and take cues from the mistakes of others. Moving to the context, like in Delhi especially, where we are operating, as a 44% of Delhi, we are supplying power South and West Delhi. And we feel that the boom is going to come in South Delhi because South Delhi is the house of affluents, and they are going to change their cars earlier than others. We have seen that Delhi Transport Corporation, which is having about 15,000 buses, and they have placed the contract for 5,800 buses. 1,500 buses already either in the pipeline or on the road, and about 50 megawatt of load is already in the system. So we have started supplying 50 megawatt of load in Delhi for 35 megawatt in our BRPL area. Such charging stations are ranging from 2 megawatt to 20 megawatt. So we are already having 20 megawatt substations, and more are coming up. And by next year, this demand, or by 26, this will be about 500 to 60 megawatt load of electric bus only in Delhi. So this is huge, and 5,800 buses will be on the road by 2025. So this also gives us opportunity for utility to move from the conventional planning to very speedy planning to have fast response to the need of our load or utility or bus load. And generally for a grid to come, it takes 2 to 3 years, but now we are providing mega scale charging station in 6 months, 9 months time. So those are the kind of speed we are targeting to meet, and we have delivered 6 projects to our esteemed DTC, Delhi Transport Corporation. And I think state utilities or the DISCOMs are the best to electrify these stations, because the charges, the premium which is being charged by the utility is the least. Like if you have any operator who is like OEM, they will charge you 10-15% of markup. But as a utility, we are charging only 2.25% to, that is all including design till delivery. So everything includes only 2.5%, and we save a lot to our customer and government. Because we are in this business, so we purchase lot of material, we have lot of service contracts, so this is one of them. So economy of scale is there with the utility. Most of the time we have material for such a small 2 to 4 megawatt of load, so we can straight away put into the place. So this will help our e-bus charging program to run in faster mode. In Delhi, there are 2 situations. One is Delhi Transport Corporation, which asks us to do the electrification up to the metering point. So metering point is generally defined in the regulation for different voltage level. But for cluster buses, about which is 50% buses of Delhi are being managed by cluster buses, DIMS, and they ask us to provide electrification up to LV level. Even though the metering point is at EHV or 3366 level, they ask us to go up to the LV level. So beyond that, the chargers are being installed by the bus operators. So this gives us very strong fit to support our e-bus charging infrastructure, and also the car operators like Blue Smart. So Blue Smart is coming up big way in our area. They have large scale 2 megawatt, 3 megawatt charging stations for their car. And challenges with us is like car stations are coming up in the area where we already have the congestion in the network. So it is making worse than the earlier. So there are challenges, but the opportunity within this is with these kind of electrification, we are also trying to have redundancy in our network. So we are able to connect the loose ends. So this is also opportunity. The regulatory provision so far in Delhi case is, and similar is with other states, up to 4 megawatt. This 11 kV up, you have to supply at 11 kV, and for up to 200 kilowatt, it is on LT. So other states are giving only, as Anand sir was mentioning, 100 kilowatt on LT, but we have provision for up to 200 kilowatt on LT, and 4 MVA on 11 kV, and for beyond 4 MVA, we have to go for 33 or 66 kV as the beat may be. In some of the area, like inside the ring road, you will have only 33 kV network. So there, if the charging infrastructure comes, we support with 33 kV in feed. And in outer Delhi, where mainly we have 66 kV, so 66 kV is the feed. For 11 kV, generally the cost is of the order of 3 crores per MVA of load, because you need from 1.25 crore per MVA is the EHV charge, so upstream charge, and then you have 11 kV line. For 11 kV line, you have material and services at 50-50, 50% by utility, 50% by developer, and the 100% of the road restoration charges is being borne by the developer. And in Delhi, the road cutting charges are the highest portion. Almost 60% of the development cost goes to road restoration charges. Almost 400 to 500, 4,000 to 5,000 per meter is the road restoration charges. So you can think of the kind of road restoration cost. That's why we always do advocacy for have dedicated corridor, utility corridor, wherein you have all the kind of utility in that corridor, and if there is any one addition of the feeder, same can be housed in that utility. That will save a lot of cost of laying of the cable and maintenance also in the future. For 33 and 66 kV, this 100% charges are to be borne by the developer. That is the present regulation. And scope with the utility is generally for 11 kV or HT. This we go up to the metering point for DTC and LV for others. But for 66 and 33, we have a switching station at 66 or 33. And beyond that, it is the responsibility of the operator or DTC to do the electrification. I'll just discuss one case wherein the change in the approach in the planning has saved a lot of money for Delhi Transport Department or DTC. Like in one of the area, Okhla, 3 locations were selected for, 3 depots were selected for electrification with 25 megawatt of load, 25 MVA of load. As per normal approach, and as the regulation suggests, we should have, because all the locations are beyond 4 megawatts, so we should have a normal approach to have 3 switching station or 3 grids, 3 HV substations for each locations. And for those locations, if you do metering at 66 kV, then about 1,500 of crores of rupees is required for that switching station. And beyond that switching station, that DTC has to put a grid, 66 by 11 kV grid, and then 11 by 0.4 kV substation to make it LV available for the bus operator to charge. So this also requires, the switching station requires about 300 square meter of space per location. For 3 locations, this you require 900 square meter of space. So now if CNG buses are X number, then the number of buses which can be housed and that depot will be less, because we have now 300 square meter for the switching station, and then subsequently 1,500 square meter for one 66 by 11 kV grid substation. So you see, for these 3 locations, ideally or the normal planning would have required 5,400 square meter of space and 180 crores of electrification cost generally. But what we have optimized and changed in the approach, we convinced the regulator that this can also be done. This is win-win for the government as well as for the utility. There is no loss to the utility in the long-term planning. At the same time, it is supporting this cause of CNG to e-bus movement, so let us support that. And our regulator was convinced and they have approved this proposal. And this way, what we have done, we have eliminated the switching station, so 15 crores is gone. We have, since there is no switching station, so 300 square meter space per location is saved. Second thing is, we have installed the grid of 66 by 11. So earlier it has to be done by DTC, so we have done. So there is cost effectiveness in that. Even with the same cost on same area, we have installed this. Then we have also curtailed that one grid for all 3 locations. We have not gone for 3 grid at 3 locations. We have said one grid is sufficient to feed the 3 grid locations. So we have installed the grid at the central point and emanated the 11 kV feeder for the other 2 stations. So this way, we are able to, in this 85 crores of cost and 2,000 square meter of space, We have saved 95 crores, almost 50% for the government, and 3,400 square meter, which can house hundreds of buses in these stations. So what I meant to say is simple change in approach from the existing regulations with the mindset to enable this journey of mass electrification, EV penetration in the country, that DISCOM can play a big role with the positive mindset. And this is not only for the bus operator or the EV, but it is good for the utility as well. When we do any electrification, we are actually trying to connect the two loose dots. So when we have electrification in the area, our system also gets strengthened. And moreover, like if we have bus charging at the off-peak times, then the load factor will also increase. We have the challenge of reducing load factor every year. When we had acquired in 2002, the load factor was 0.55. Now this is at 0.45, 0.46. So every year load is increasing, but not the energy in the same pace. So that is affecting our top line. Another case, just I will touch upon the similar way, is the Najafgarh area, wherein 6 such depots has come up for the electrification. Ideally, there would have been 6 switching stations, 6 grids, 6 11, multiple 11 by 0.4 kV substation. But this simple approach of planning, we have saved about 200 crores for those 6 locations. So there is huge potential in the planning. Also, we are also trying to co-locate, though the regulation says that such electrification 100% cost will be borne by the developer. But for the station or the location where we already require, we also require a grid in that location, then we also put money to develop that location, not only to optimize the cost, but support with our money to develop those grids at those locations. This is win-win for DISCOM, utility, as well as for the DTC or transport department. So change in planning approach, speedy planning is very important to support this cause. And we always request our upstream, the state transmission utility, to also come up with this pace, because their readiness is also very much required. When we are adding 600 megawatt of load in 2 years, then probably 1500 mega MVA capacity is required, and for 1500 capacity, at least 5 more additional grids at 220 or 400 kV level will be required. And for that, the starting point is already yesterday. So that needs to be done. One of the challenges I would like to emphasize here upon is this such bus charging is generally coinciding with our peak. And this is very heavy on our pocket as a DISCOM, because at those times we are purchasing power at the rate of 10 rupees, 12 rupees a unit. And the same time, bus is also charging at the rate of 4 rupees. Even with the peak surcharge of 20%, it comes to 4 rupee 80 paisa. So this is heavy, very heavy on our pocket. When we will be adding 5,800 buses by next year, this will be the huge impact on our bottom line. So this is the one thing I think with this. If policy advocates are there, and if they pitch in, and this bus operator can be made responsible, that you have to support this peak curtailment rather than adding to the peak. And we see huge scope in battery as a generator. As you were saying, Anand sir, that we are not like a truck operator, but the battery company, but you will be soon a generating company. So that we have very high hope from such truck and bus electrification EV journey. And we see that during these hours, we will be having source from the bus or school bus batteries. So in that nutshell, I would say that cooperation or very in sync coordination of utility or DTC or the bus corporation and the operator is very much required from the day one. If we cannot start after when a load is actually required, but with N-3, N-2 years a priori, so that we can, as a utility, we can advise you, we can assist you where to put the EV stations and where to have like at least car mass charging stations like Blue Smart, we are advising that where our grids are underloaded, you bring those stations near to our grid so that it will be cheaper for you and it will be utilization of our grid, which is already underloaded. So those are the kind of assistance we are providing, and this if we work this way, it will be win-win for all, and we will be like our load factor will increase this way. So we are looking from that perspective also. Cluster-wise planning is very essential. If you do planning in bits and pieces, it is going to always cost more, and it is the sustainability or the scalability will be missing in the future, and we have to maybe reinvent again, because we have seen in some cases, because 4 MVA is the limit, so the transport department has applied for 4 MVA, and when actually bus was connected, it was 7.5 MVA. So that infrastructure is now not able to support that kind of charging, so they have to either move the buses from there or increase with the EHV or grid at that particular location. So that is very important. So I also personally believe that the bus operator business is to operate the bus, not to operate the basically utility business. So for utility business, we are there, and we have, even with the 10-20% of addition in the network, we have sufficient manpower, and that will be the cheapest for you. So bus operation and maintenance better be left with the utility, and generally is the case, but in some case we have find that separate team is created, separate inventory is created, separate spares are created for such kind of maintenance. And tariff design per kilometer has to be seen that actually operator is responsible for payment for the electricity cost. Generally in Delhi presently it is like DTC or the transport department will pay for the electricity. So the operator is not worried that at what time I will charge. So it is like cost is being passed on to the transport department, so they are less worried. So if it can be integrated, then only they will think of putting into the place correct things. So thank you so much. This was the few points I would like to highlight. Thank you. Thank you so much.
Thank you very much, Pramodji. Thank you for putting all the good work. Generally, we see money being wasted, but we saw 95 crores being saved. So thank you for all the hard work. And I'm really interested about your 2 load curves, wherein we can really support you to get into a study and understand that what can be the best solution. Maybe storage can be also one option wherein we can solve this. And I have a good news for you. A publicly owned utility, UP is planning to get into the charging business, because for them, there is no cost of land. They have enough land, substations or maybe subdivisions. And there is no 6 months time, waiting time to get the electricity connection. So they have all the advantage what can be. So this is also a good business to get into. Thank you. Thank you, Pramodji. Now I would request Mr. Sujit Nair, who is CEO and co-founder of FIDE, to give you a presentation. This topic is so interesting that we would love to sit here till evening and talk about the trucks and buses, but I would request if we can bind quickly so that there is next session. So quickly we have to bind. Thank you.
5 minutes, 10 minutes?
Yeah. Okay. Take your time. It's just, just the message I was passed.
Sure.
Thank you.
So good afternoon, everyone. So I am going to make a few confessions before I start. One, I am nowhere an energy expert or pretty much a novice here. So I've come here to learn, and little did I realize that Reggie and Anand will put me on a dais and speak about something of my work with Beacon Protocol, the work I do. I'm also here to share a few ideas, a few frames, which is, I think, completely away from probably what we are talking about today in terms of energy, clean energy, e-mobility, and try to combine this very different way of thinking into the mainstream thinking about green, e-mobility and others. So I'm going to make a few attempts on showing you some ideas of how India would probably approach this problem at population scale a little differently, and what are the early signs of that? Yep. About myself, while I'm the CEO of a not-for-profit foundation that I co-founded with Nandan Nilekani and Pramod Verma on this protocol, and I'll talk about standards, and these standards are very different from some of the standards you've mentioned that you heard here today. But I think the two things that define me is that I'm very passionate about the idea of internet, how internet evolved and how it continues to evolve and change our lives pretty much on a daily basis, and how India is building a similar idea almost every 2-3 years. And I'm going to talk about that and see how does that actually make sense in the context of what we're talking today on energy and e-mobility. Now, this is the idea that India has been working on for the last decade and a half. Now, let me play back time to 2009 when mobile phones, iPhone was here. Any guesses on what would be the banking penetration in India in 2009, as recent as 2009, when pretty much everybody has smartphones? India's banking penetration was 18%, less than 20%. We're talking about modern India in 2009. About 500 million adults did not have bank accounts. Now, quickly fast forward, in about 7 to 9 years, India's banking penetration jumped to 85%. I know these numbers are startling. Every time I say that, even I get goosebumps. This happened in 9 years. Bureau of International Settlements did a study across the world and said any economy to make that kind of a leap would take about 50 years. India did that in 9 years. Now, this is a very, very interesting phenomena that keeps repeating in the India story thanks to this little model of growth that India is putting together called digital public infrastructure. It started with its first version, which is the creation of Aadhaar project. Now, India did not solve for banking by putting more bank branches in the villages. India did not say, okay, rural needs more banks and let the people, branch managers, leave their kids in the city for education and let's go to the villages and open bank branches. No, it did not do that. India did this problem very differently. India did not take banks to the villages, India took banking to the villages. And there's a big difference. Because what were the universals in 2009? The universals in 2009, when I say universals, the undisputable facts, the indisputable facts. India realized that India will probably escape the PC adoption, computerization, and directly leapfrog to mobile phones. And you have the reality here, 900 more smartphones in India. We know that India is going to be a mobile-first economy. India used to consume 1 GB per capita per month about 9 years ago. Today, India consumes 1 GB per capita per day. We all love our IPL videos, right? But the fact is that we are heavy data. We are a data-rich economy. So how did we, therefore, take advantage of a universal change that was happening globally and pretty rapidly for India and rethink this problem of financial inclusion and access banking? We said everybody's going to have a mobile phone, so can we put branches in their mobile phone? And the way they did it is to solve for some of the fundamental problems of banking, which was people did not have an ID. 400 million people in India did not have a legal ID to claim who they are. Forget claiming citizenship, forget claiming benefits and rights, they just could not claim. And that was the first building block as a digital public infrastructure that Aadhaar came together. Now I'll stop here. You pretty much know the story that came after, but this is a way of thinking that is called digital public infrastructure. It's not a solution, it's not a platform, it is building what is called the digital public roads, digital public rails on which public and private innovation happen. How did it happen? You can see what happened. We all heard of the geo effect. Because there was an Aadhaar, and Aadhaar created the next building block called electronic KYC, which is the know your customer norms to open a bank account or a telecom. For example, Jio as a company used this public infrastructure of Aadhaar and eKYC to go from 0 customers to 150 million customers in 9 months. It became the largest telecom subscriber in a little bit no time. It is today in India possible to get a SIM card in 3 minutes, open a bank account in 3 minutes, thanks to the Jan Dhan Yojana, the JAM Trinity. We have this rapid penetration, all because there were these fundamental, foundational building blocks, not solutions, infrastructure that enables multiple use cases, multiple innovation on top. Just like how when you have roads, the village becomes a town, town becomes a city. when you have digital roads, economic development in the digital economy spreads fast. Banking access increases. The cost of access banking went from 3,000 rupees per account to 1/10 of a dollar. And that's because digitally, you can distribute access very quickly so long as you have these enabling building blocks. Maybe the version 2, and I'll stop here before I get into why I'm saying all this in an energy conference. The version 2 is India was a very cash-heavy economy. Our electronic payments were as low as 3%. We were doing 150 million electronic transactions as a country. You know, we have this magic number in India. Everything stops at 20, 70, 100 million. For a country of 1.2 billion people, nothing goes beyond this number. We always get stuck because that's the only amount of formalization India's economy has seen. But with UPI, as we all know, anybody who doesn't use UPI today here, I don't know when was the last time I went to ATM to withdraw cash. UPI came about in 2006, 0 transactions per month. Guess what was the transactions it clocked last month? 12.3 billion transactions per month. This was a time when electronic transactions like cards were doing about 100, 150 transactions a month in 2016. In 6 years, in 7 years, UPI went from 0 to 12.5 billion transactions, and UPI is not an app. It is the digital rail, open standards, digital building blocks, which led to creation of PhonePe, Google Pay, whole lot of it, 200 banks are on it. There are 200 different UPI apps. And today, a Tendo coconut water in Bangalore would not even look at his mobile phone. He'll show you a QR code, and then there's a boombox saying, okay, 25 rupees received. That's the scale and speed of access that digital public infrastructure has created with things like Aadhaar and UPI. I don't even have to talk about the power of FASTag. How many people now wait at lanes endlessly? You're zipping through, and that's the FASTag. So these are all examples of a way of thinking called digital public infrastructure, and this is what India is telling the world as a different model of growth. If India has to leapfrog from nothing to far ahead to be the third, fourth largest economy, G20, G21, everybody endorsed this idea of a digital public infrastructure as a different model of growth. Now, India is now on to version 3 of this digital public infrastructure. I don't know how many of you have heard of ONDC, Open Network for Digital Commerce, which is the UPI for commerce, or Unified Health Interface, which is the UPI for teleconsultation that started during the pandemic. How many of you from Bangalore tried Namayatri as an auto rickshaw? There's a peer-to-peer auto rickshaw where the driver does not have to pay a middleman any commission like they pay to Uber and Ola. They get 100% of their rides directly, which is the whole digitization revolution, the version 3 that's happening beyond banking, beyond payments, to a whole new world of commerce and fundamental economic transactions between consumer and provider. And that's the effort that I'm part of. I'm one of the co-founders of the larger thinking around ONDC. It started with a paper in the pandemic. Bases this idea, can we create the UPI effect for commerce and economy? And that led to the creation of ONDC and some of these projects. And the protocol, the standard, just like how UPI was a standard, a 1.5-page document that has led to 12.5 billion transactions a month, is a 1.5-page standards document. Beacon protocol is probably not 1.5, but 2 pages. That is probably doing the next wave of change that India is doing, which is, I don't know if you know, ONDC does about 7.5 million transactions a month. It's just about a year it got started. It was doing about 1,000 transactions a month as of last year, and the numbers are increasing. We have more than 500 cities connected to ONDC, 70 platforms connected to ONDC. The Paytms and Ubers and Amazons are all coming. 3,000 platforms are all joining this revolution because it is a way India is thinking about how do you identify this fragmented markets, broken logistics, fragmented logistics sector, Kirana fragmented, not digitized, to a whole lot of the gig workers and restaurants and all of that, and create a unifying way of deepening access to digital across the country so that everybody has a chance to do business online and expand like the UPI effect. Now, I'm here to say, pose this question and learn as to, is there a UPI moment for energy? Is there a UPI moment for energy at population scale? Is that a possibility? Because if we are in exciting times, we just heard the fellow speakers, definitely something that I've learned in the last 1.5 hours, is there an opportunity? Is there a change that we are witnessing in the space. I don't have to extol what's the change here. We know how the energy sector is fundamentally getting revolutionized. We all know, of course, India is consuming demand global at a per capita level 10% more than the last year, and it's continuously increasing. But what is interesting is that there is this rapid adoption of green energy. We heard Modi ji talk about how 10 crore households are going to have rooftop solar. We are talking about significant reduction in cost of battery, the solar cost plus battery cost coming down. We saw the bids in Ahmedabad about the tender for solar plus cost coming down, pretty much comparing to new coal as a source of energy. And we said that everybody is becoming not a consumer of energy, but a prosumer of energy with solar. The battery costs are coming down, the energy density is increasing, EV demand is hitting, EV is inevitable, that's happening, everybody is buying it. Given all of this, how are we solving these three vectors of cost, reliability, and clean energy, while focusing on this big shift? We think this is perhaps the iPhone moment of 2009. Are we going to miss this bus, or are we going to ride on this bus? Because this is probably going to give India the next leapfrog moment to fundamentally see how we consume energy in this country. And it is with this idea, we're realizing that there are significant shifts that are happening, not just on the generation side, storage side, and the demand side. There is a significant amount of effort that's happening. I was talking, by the way, to a few EV charging companies. I was surprised to know that India already has 65 different EV charging operators, or more. The count is simply going up. And what's funny is that the EV adoption is not actually scaling up to the kind of investments they're making in charging infrastructure. The net utilization, the average utilization of an EV charging company in the public, forget even the private, in the public chargers, is less than 5%. And it's not a different story outside of India. Outside in US, I was told outside of Tesla, the numbers are as abysmal as that. So on one side, we have found everybody wants vehicles to be electrified. On the other side, the charging companies are coming up and saying, hey, this is the next wave. Let me put up a charging point, be the charging point operator and make money out of this, but the utilizations are nowhere going. So how do we therefore find a way to accelerate adoption, utilization when these trends are happening? And that's probably where I thought there is a DPI thinking to fix this maze that you see on the slide. Everybody is getting digitized and everybody is doing this in isolation. There are 65 charging companies, each of them saying, oh, you want to use my charger? Download my app. Use my app to find me, to go where I am. And the driver on the other side, EV user on the other side is, oh my God, the reason I'm not buying this car is because I have this quote unquote range anxiety. I don't know if I'll find a battery, I find an EV charging that I can use, I have to figure out which EV charger, which app I have to download. Not happening. Payments, same problem. We had different types of payment apps. The payment adoption was so less, suddenly UPI came, it doesn't really matter. I can use a Google Pay to pay a Phone Pay or anybody, and suddenly the payments took off. So there is an opportunity to unify this already decentralizing fragmentation trend that is happening in the country with green energy, a clean energy transition, and think of a network like UPI for energy. And that's where fundamentally we are thinking about an idea like ONDC called the Unified Energy Interface in India. I already have about 20 energy companies who believing to be part of it. Some of them are EV charging companies, some of them are energy warehousing companies, some of them are battery second life monetization companies, all coming and saying, is there a way, instead of each of us individually solving the problem of driving adoption and incurring cost, we all heard the cost structures just now, can we collectively create a shared infrastructure digitally so that we create rapid cost curves of decline? And I want to again quote UPI. When UPI was launched, the two big entities, the biggest bank, no need to guess the name, and the biggest wallet company said, we don't need UPI because I think 150 million, we are very happy. Little did they know that the market is going to 12.5 billion. India's opportunity, here are the numbers. In 6 decades after independence, the number of vehicles Indians bought was less than what we bought in last 1 decade alone. That's the scale, 100 years of automation industry. We're going to change that habit and make them go to EV. Everybody is buying cars, we're trying to get, and then suddenly you said, no, you're not saying to buy cars, you're supposed to buy electric cars. And then you have the range anxiety problem. So how do we create a population scale shift like UPI? And that requires a certain way of thinking, and we believe one way of doing it is to digital public infrastructure, and that's where unified energy interface comes in, an open network, an energy internet, an energy transaction internet that will deepen the access of discovery, fulfillment, post-fulfillment of any buyer consumer expectations being met. So today, if I have a demo wherein you can discover any EV charger of any platform using a WhatsApp. It's not that WhatsApp Meta company is involved. A WhatsApp bot can connect to anybody. Despite we having global standards around OCPI, Ministry of Science and Technology realized that it requires a different way of thinking, a different form of solving this problem, and they're using Beacon protocol, which is fully open sourced, fully free, open source. The moment we wrote the protocol, and I'm a tech journalist, I'm an author of the protocol, we made it free. It's Nandan's philanthropic effort. It's a UPI version. We just made it free, and that open standards is sort of enabling this conversation on EV charging, battery monetization, etc. I will not talk about the tech standards. It's a way of how, okay, let me give you this way of putting this together. Today in the digital world, if you want to order Uber ride, you need to be on the Uber app, correct? Which means the consumer and the provider needs to be on the same platform. Now, if you're on Airbnb, you need to be on Airbnb to find an Airbnb house. If you're on Swiggy to find a restaurant, you need to be on Swiggy too. So there is the structure that we have come to live with in the digital economy, wherein the consumer and provider need to be on the same platform. And that's what is called as a coincidence of risk. It's a systemic risk where unless and until you both are on the same platform, you cannot discover each other and talk to each other. This is the same problem that EV charging is facing. This is the same problem battery monetization is facing. This is the same problem everybody is facing, because the expectation is, if you want to find an EV charging station, I need to be on that platform where the EV charging station is made available. We are changing that. UPI changed that. For example, if your friend is on PhonePe, you don't have to be on PhonePe to send money. And that's how internet worked, by the way. You're on Hotmail, doesn't mean that I have to be on Hotmail to send you an email. I can be on Gmail, I could be on any email. Similarly, on mobile phones. If I'm on Airtel, I don't expect you to be on Airtel to make a call or receive a call. You could be on any phone. This is the concept of interoperability. We are bringing interoperability in the way we discover, find, order EV charging station, an idle battery of a school bus which is lying idle for the rest of the day, and saying there is a 250 kilowatt battery lying idle, and we just heard the cost of the battery is pretty much 80% of the vehicle, of the cost of the vehicle, of 50% or 60%, and it's lying idle for most part of the day. Is there a way we can make that battery, idle battery, through V2G or independently, be available for an EV charging station, or be available to push green energy back? There are so many millions of batteries that are all fragmented. Are we going to bring them into the grid and increase the green content of the grid? That requires handling these micro-fragmented capacities of resources, interoperable and discover as one common internet. And that's the essence of UEI, and that's what Beacon does as a protocol. By the way, Beacon protocol as such is not an idea that's just born yesterday. In India, we have 5 networks, including ONDC. We have health, UHI, NHA uses this Beacon protocol for teleconsultations. We're using it for education and skilling. And outside of India, we're doing about 40-45 projects, including some work with microgrids and community solar in places like Netherlands. It's a fully open standard, and we have a global adoption curve. In Brazil, we are doing education and other things. But we believe there is a need for an underlying web, kind of a transaction web kind of fabric, on which many such energy standards, whether it's on demand response, OCPI charging, all of that can be overlaid to create this sort of a groundswell Cambrian explosion kind of an effect, like what internet did or UPI did. And that's the essence of Beacon. There is a live demonstration of this that's happening in Bangalore. I don't know if you've heard of companies like Pulse Energy and Kasam. They are already on UEI doing transactions on this grid, wherein through a WhatsApp you can discover any charging stations that are connected to these platforms, and they in turn are talking to an energy banker, who's Sheru, for example, who is actually a virtual energy warehouse. He's a warehousing company not buying storage, battery banks to store energy on behalf of its clients. He's actually discovering idle battery using UEI and creating virtual storage. So what is the cost of storage for Sheru? If it's tapping into idle batteries, if you have 50 buses with 300 kilowatt in a depot in say Dwarka, can I tap in 4 or 5 hours of its idle time? So there is a virtual energy warehouse that's happening, all because it's so silly. All it required is everybody speak the same language, and that is what Backend does, and it's trying to create an open network, and we're already in conversation with multiple states to do this, and companies like Turno, which is an EV financing company with a battery buyback. And their thesis is, if the battery, when the efficiency comes down to 80%, it's no more good for EV vehicles, so can I take back the battery and create a second life? How are they creating second life? They're putting solar charge into it and making it available for companies like Sheru or a Bescom in Bangalore, and therefore use that solar plus storage cost factor to create cheap energy supply right in the last mile and make energy decentralized assets come to life. So you're monetizing an idle battery, which means you're pretty much reducing the total cost of ownership of a battery for a bus. And if you can do that, you're actually making green energy come to EV charging. In fact, there's a case where Pulse Energy is able to give green energy because of this integration on a network, 2 rupees lesser than the grid energy. Because there's an economics that plays out because it creates that opportunity to find an idle, unwanted resource and create monetization value out of it. I know I didn't have time to go into details, but I'm giving you the highlights. This is the site that is already live, and we're trying to demo that in a few other states. And this is pretty much the summary. If you want to think, what did I just say in the last 10 minutes? Is that if the world economy flourished because we created roads and bridges and public infrastructure like electricity grid and everything, and that led to economic growth, why aren't we doing a digital public infrastructure in the digital world to unlock this kind of a public and private innovation? And that's what fundamentally is the essence of UPI Aadhaar. We are trying to bring that into commerce and energy through ideas like Backend Protocol. Thank you so much. Thank you.
Thank you, Sujit, for your wonderful perspective. Certainly, this is going to help us while doing our pilot. I inquired that how we are charging our trucks. So the technology partner who are running trucks for us, they said that we have to log into one of their website. Then we have to pay the money in advance. Then we have to come here, plug in, then we'll get a OTP, and then when we confirm it, then we get the charging starts. So before them, I felt like giving up. It's like a bigger exercise than running the electric truck to charging it on the highway. So certainly these kind of technologies or maybe platforms can help, and then there is already, backend protocols or support is available in EV business. OCPP, we have been talking, we had a session in OCPP regarding OCPP. So backend is ready. It's only the front end thing where we interact with people and we can integrate both of the isolated system, what can do magics. Thank you. Thank you very much. Now I would request Mr. Vijay Sankar, who is Executive Director, BOCI, please come to the stage.
Good afternoon, all of you. Thank you, Mr. Singh, for giving us opportunity to speak about the operational issues. So all of the other panelists were talking about the charging infrastructure and adoption of electric mobility. But we are from the Bus and Car Operators Confederation of India, and we have more than 18 lakhs bus plying on the Indian roads. So we have the first-hand experience about the issues around the AV adoptions. Like awareness and availability. Awareness among the private bus operators are very less. The absence of proof of the concept, and the showroom are not available at OEMs. The products are not displayed there. The ready availability of buses are not available. Uncertain delivery time. If you order the bus today, you cannot estimate when you will receive the bus. The legislative issues are there. like policy on the electric vehicle differs from state to state. MB tax rate differs state to state. Motor vehicle permit rules differs from state to states. The operating issues, range anxiety. We are not sure this whether this EV, how many kilometers we will run if we charge it. Because the operators, the OEMs are claiming 350 kilometers, but when you operate it, it goes around 250 kilometers. So long-term after-sales service assurance by OEM, availability of spares in open market, shortage of trained manpower. The financial issues are difficult to raise debt equity, interest rates on debts are high, period of payments is short, uncertainty of resale value. The infrastructure challenges in adoption of electric mobility. The absence of infrastructure, getting electric connection is required in kilowatt power, and it takes long time to reach to that place. Absence of common parking spaces to put up the charging infrastructure. Rate per unit varies from place to place. Type of charger is not common for all buses. The solutions: run countrywide awareness campaign among the private bus operators. OEM shall open experience center come showroom at India's top at least 20 biggest cities. Uniform EV permit and taxation policy across country with defined per unit per rate. OEM to provide written assurance of performance and AMC rates for at least 10 years. Trained manpower for electric vehicle. Standardization in charging infrastructure. At parking lot and STU's premises, development of common charging infrastructure. RBI should bring in e-lending under priorities, common forum for meeting of green funds with bus operators to bring in equity, financial assistance by central and state government, tax and toll waivers to be given to the electric vehicle operators. That's all. Thank you.
Thank you very much for being so quick but very relevant points. Mostly I'll touch upon this RBI should bring in e-bus lending, because once we are talking about trucks and buses, trucks are mostly the unorganized market, wherein being a owner of one truck or two truck, I don't have the courage and capacity to go to the World Bank and say that I need a cheaper loan to buy a truck. So wherein RBI or maybe any state bank have a bigger role to maybe a back-to-back settlement, wherein we can go to the local bank and they have a back-to-back settlement with a bigger bank, wherein the cheaper finance can be made available. And that is also one way to look at it. And I am sure that this is we are into a very cost-sensitive market. So I'm sure that that is going to lead a bigger role in terms of adoption of electric mobility. So Neha, now it's your turn, and I understand you had a transport problem, but if you can, I think you don't have any present PPT you don't have. So I would request you to share your perspective where you look at electric mobility sitting at MG Motors, and then what are your challenges? And I'm sure that you have gone lots of perspective that how we can solve it. At least we know that there is a solution. So please.
Thank you so much. And first of all, I would like to thank SDO for providing this opportunity. So while we are talking on the... Yeah, hope I'm audible now.
So while we have heard, our fellow panelists, they have given such deeper insights on the challenges as well as opportunities when it comes to especially the highway electrification. I can add my perspective, especially from a perspective of passenger vehicles, because when it comes to electric mobility, we are seeing an adoption over the last few years in the passenger vehicle segment as well. And here again, charge anxiety and range anxiety are the two main concerns in the mind of customers when it comes to adopting an electric vehicle. So at MGI, when we started our journey around 5 years back, we took a stance on this, and we started working on I would say on a structure which we internally called a 6-way charging infrastructure. We also noticed that, especially for an electric vehicle, when you buy an electric vehicle, it is also a kind of a change in the lifestyle. Because as a user of a petrol or a diesel car, we are comfortable with the availability of the fuel stations as and when required. But when it comes to electric vehicles, we need charging. We need charging solutions right from our home or offices where we spend most of the time, and also public charging infrastructure, and likewise different solutions also. So we work on a concept called 6-way charging infrastructure, where it starts with a home charging, where a 3.3 kilowatt charging cable, for example, is provided with the car, which is compatible with a 15 ampere socket, which you can plug and play anywhere while you are traveling. This is kind of a portable charging solution. Then as step 2, we provide a home charger, which is generally a 7.4 kilowatt charger, which get installed at your homes and offices. And this takes care of your home charging, which we have seen that, in the last years with the customers, that 85 to 90% of your charging needs get through your home charging solutions itself. Then it comes the third way, which is called the public charging, is basically a charging infrastructure when you are traveling. It can be intra-city, it can be intercity as well. And this is where we have tried to create this charging infrastructure, especially starting from our dealerships, which is a 50 kilowatt or a 60 kilowatt charging station, and it can give you a top-up of, say, whenever you need it, as and when, on the go basis. But when it comes to highway charging, especially with the long-range vehicles, long-range cars coming into market, obviously people would like to do an intercity travel, and this is where the highway charging comes into picture. Also, when it comes to highway charging, one very interesting thing, or I would say a challenge that comes in mind of people, are discoverability and reliability. So there is also a phenomena called reliability anxiety, where the question comes in mind that whenever I'm going to a charging station, is the charging station working? It is available? Will I be able to access it? So here, as an initiative, what we started working is to work with CPOs, with oil marketing companies, to create this charging infrastructure across the key highways. Because even as a EV customer, whenever you are taking a long distance travel, you are also looking to stop at key spots at a highway, where you might also would like to take a break for food or for refreshment. And this is where it provides an opportunity, and it is also a safe and reliable space where you can take a break with your family. And meanwhile, while you are taking a rest, you can also do a charging at these highway locations. So this is where electrification, and I would say a highway charging or a destination charging concept, we started working on. As a step 5, we started working on a concept called community charging. So we have an initiative which is called MG Charge, where we are tying up with key public locations, be it school, colleges, universities, hospitals, malls, or any key locations within the city, where we can create a charging infrastructure, and this provides again a confidence to the customers for an easy accessibility of the charging station. It is very encouraging to see a lot of players now in the ecosystem. As Sujit also mentioned, there are so many CPOs that are coming up. This ecosystem is developing, and yes, one key, I would say, the demand of the time is aggregating all this infrastructure for the ease of convenience, ease of discoverability, and this is where platforms like UEI can play an important role. Also, I think when it comes to innovation in the electric mobility and charging infrastructure, one of the other initiatives which can create a big opportunity area is the usage of energy storage when we saw the concept of BESS. So here again, we are working with a lot of our partners in creating or repurposing electric vehicle batteries. Because when we call an end of life of a battery life, there are two ways. Either you can recycle the batteries which are damaged, or you can extend the life cycle of a battery with a concept of repurposing. And this is where life of an electric vehicle battery, be it buses or four-wheelers, these can be extended by putting them in appropriate energy storage use cases. One such use case can be stationary storage, which Mr. Pramod was also talking about. The other use case, like we have recently announced a pilot on it, was to create a 100% off-grid solution of a charging station which is powered by repurposed EV batteries. So these are the kind of initiatives which I think, these are again different use cases under pilot, but this add to the innovativeness in terms of the charging solutions, because this space is evolving. And like any new industry or segment, these are the use cases which are coming through the customer experience and customer requirement. So in a nutshell, I mean, these were my closing points with respect to the innovation and the emerging trends in the electric mobility. Thank you.
Thank you, Neha. Thank you very much. And I think we have slipped on time by 20-25 minutes. So we can do question and answer during lunch, and then let me bind this session. So now I would thank you for being a wonderful panel. I'm just closing up, otherwise I could have summarized everything, but we will share all the takeaways from the session to everyone, all members present here on the dash, off the dash. I would now invite President ISGF to please come on the dash, and I would request Vivek to arrange a token of appreciation mementos for all the speakers around here.
I would like to introduce Mr. Sridhar Chari to kindly get the memento, please. Miss Neha Jain, kindly get the memento, please. Mr. Biju PT, kindly get the memento, please. Mr. Pramod Kumar Misra. Mr. Sujit Nair. Mr. Vijay Shankar. Mr. Anand Singh. Please kindly get the memento. Now we can get a quick group photo. Please come forward.